Hey science explorers, ready to crack the code of chemistry? Today we are going to tap into the most powerful tools in sciences, which is the periodic table. We are going to uncover how the elements are arranged in the periodic table, why the metals and non-metals behave differently, and how we can predict the properties of elements by looking at the trends in the periodic table. Also, we are going to zoom in to the special groups such as your explosive alkali metals, the mighty transition metals, the colorful halogens, and your chill noble gases. So let's make the periodic table your new best friend in chemistry. So students, before we dive in this interesting chapter, let's first understand what all topics we are going to cover in this video, okay? So the first is periodic table. So I'm going to introduce to you with the periodic table. We will talk about the number of groups, then periods, what are groups, what are periods, then period number, group number, metallic character of element. Now what is metallic character? So the tendency of metals is to donate electron, right? So this is what metallic character is. So we are going to study about that. Then we will talk about the properties of metals and non-metals, then periodic trends and electronic configuration, then predicting properties. How can we predict properties of an unknown element, okay? Then identifying trends. So let's start with the first topic, which is your periodic table. So you must have seen the periodic table. Here we have 118 elements and in that over 100 chemical elements which have been isolated and identified, okay? Each element has one proton more than the element preceding it. It means I can say that the whole complete periodic table is arranged in a way where each element is placed according to their increasing atomic number, right? So let me write down here increasing atomic number. What do you mean by atomic number? Atomic number means the number of protons. Okay, for example, hydrogen atomic number is 1, helium is 2. It means number of proton present in hydrogen is 1, in that of helium is 2. So they are arranged in a way that they have that one proton more than the element preceding it, right? Next is, this is done so that elements end up in columns with other elements which have similar properties. Now what are columns? These vertical lines, okay, these are known as columns or they are known as your group, okay? So there are in total 18 groups present and periods are these horizontal columns, okay? So these are known as periods, the horizontal columns, and they are 7 in number and groups are 18 in number, okay? So they are arranged in increasing atomic number and they are arranged in a way that every column, the elements present in each group shows similar properties. Why? Because all of them will be having same number of electrons in their outermost shell. Okay, next is elements are arranged on the periodic table in order of increasing atomic number. All right, this we already discussed. Next is the table is arranged in vertical columns. So the vertical columns are known as groups, which are 18 in number, and the rows, the horizontal, those are known as your periods. So there are 7 periods and 18 groups, right? I hope this is clear. This was just an introduction of your periodic table. Next, let's move on to the period number. So what is the period number? So there are in total 7 periods, as I told you already. 1, 2, 3, 4, 5, 6 and 7. Elements in period 2 have 2 electron shells. Elements in period 3 have 3 electron shells. So basically what they are meaning to say over here is each period, like for example here it is P1. So hydrogen will be having 1 shell, okay? So we know that its atomic number is 1 and the electron it contains is 1, right? So I can show it like this. This is your nucleus. I am writing Nu. And then the first shell will be having 1 electron, okay? This will be the like diagrammatic representation of shells in hydrogen. Similarly, if we talk about lithium, so what is lithium? Lithium is your 3, okay? Atomic number of lithium is 3, and so we can say that the electrons present in its outermost shell will be, so if I have to write the electronic configuration of lithium whose atomic number is 3, it will be 2, 1. So it will be, this is the nucleus, this is the first shell where 2 electrons will be present, and then the second shell where just 1 electron is. So basically period number tells us about how many shells will be present. Okay, so for example, period number 5 will have 5 shells. So 1, 2, 3, 4 and 5. Okay, so can I say that as we start moving down the group, the size of the element increases, or the size of that particular atom increases. So as we go down, the size increases. Why? Because the distance between the nucleus and the outermost shell increases as the number of shells increase, right? So let's move on to the next, which is your group number. Now what is the group number? The vertical lines. Okay, these are the groups. So now let's see what will the group tell us about. So groups are the vertical columns that show how many outer electrons each atom has. Now the period number told us how many shells are present, but the group number tells us that how many outermost electrons or valence electrons will be present. Okay, they are numbered from 1 to 7 with the final group 0 instead of group 8. We will talk about group 0 in detail in upcoming slides. Then group 4 elements have 4 electrons in the outermost shell. Outermost shell, group 6 will have 6 electrons in their outermost shell, and so on. Okay, the group number can help us determine the charge that metals and non-metal ion form. Okay, now here is the periodic table. Okay, let's check. For example, this is your group 1, 2, 3, 4, 5, 6, 7 and 8. Okay, we are going to deal with just these 8. Rest of them you don't have to take care of that. We will just be dealing with these 8 groups. Okay, now what were they saying? Group number tells us the information of number of valence electrons. Okay, in short, valence electrons. So hydrogen atomic number is 1. Its electronic configuration will be 1. So let me write down here 1. Then what about lithium? Lithium atomic number is 3. If I write the electronic configuration, then it will be what? 2, 1, right? So the outermost shell electron will be having 1 electron again. Then when we talk about sodium atomic number is 11. If I write the electronic configuration, it will be 2, 8, 1. So here did you notice that all these elements which lie in group 1, all of them have 1 electron in their outermost shell. Okay, now let's check for group 2 also. So group 2 is beryllium. First element is beryllium. So beryllium atomic number is 4. Right? We know it is 4. So how do I write its electronic configuration? It will be 2, 2. Then what about magnesium? Magnesium is 12. If I write the electronic configuration, it will be 2, 8, 2. Then let's talk about calcium. Calcium is 20. So if I write the electronic configuration, it will be 2, 8, 8, 2. It means here we can see that there is a pattern which is present, that all of them will be having same number of valence electrons, and hence their valency becomes +2, and here it becomes +1. Okay, what is valency? Basically the number of electrons any element has either donated or gained to achieve the outermost, to achieve the stable outermost electronic configuration, right? So here similarly boron, so it will be having 3 electrons in its outermost shell. Boron atomic number is 5. If I write the electronic configuration, it will be 2, 3, hence 3. Similarly, aluminium is 13. If we write the electronic configuration, it will be 2, 8, 3, again 3. Okay. Okay, next is carbon. So 4 electrons, therefore all of them will be having 4 valence electrons. Similarly 5, so all of these will be having 5 as their valence electron. Now their valence electrons are 5, but their charge will be, they will gain 3 electrons to achieve their electronic configuration, complete electronic configuration. So their valency will be -3 because all of them are metal, so they will have in negative. So -3, -2 and -1. This is going to be your 0 because this is almost stable. This is already stable. Why? Because like for example helium, 2 is the atomic number, and if I have to write the electronic configuration, it will be 2 only. So if any element has already the fully filled electronic configuration, then it is said to be stable, right? Similarly neon, 10, writing electronic configuration will give us 2, 8. Octet is complete. Okay, it means it is stable already. So the information which we get from the group number is that we get to know their valence electron in whatever group number they lie. we can get the information about the number of valence electrons, and hence we can get an idea of their valency also, right? And what about period? Period tells us about the number of shells, right? So the group number can help determine the charge that metal and non-metal ion forms. This we already discussed. For metals, the group number corresponds to the number of electron it will lose to achieve a full outer shell and the charge on the metal. For example, sodium is in group 1. It will lose 1 electron and it will gain +1 electronic configuration. Magnesium is your 12, right? If you write the electronic configuration 2, 8, 2, it has to lose 2 electrons and therefore it will have +2 oxidation state, okay? So +2 will be the charge over it. Next is for non-metals. So non-metals, as I already told you, the oxygen nitrogen group. So group 7 and 6, they will gain 1 or 2 electrons. They have to gain electrons, okay, to achieve the noble gas electronic configuration, and hence they will possess a negative charge over it, right? Now let's talk about another important thing in your periodic table, which is oxides. So in the previous chapter, we have already discussed about what are oxides and what are the types of oxides. So there were basic oxide, then your acidic oxide, and then your amphoteric oxides, okay? Or I can say that there are few metalloids which are present, which can behave in both the ways, okay? So basic oxides. What are basic oxides? The metal, when it is joined with or combined with oxygen, so the metal oxide is actually basic in nature, and hence they are known as basic oxide, okay? All of these blue in color are your metals, right? Then the yellow ones are your non-metals. So non-metal oxides are your acidic oxide, for example NO2 or your CO2, right, or SO2, all of these. N is non-metal, carbon is non-metal, sulfur is non-metal, hence their oxides will be acidic in nature, whereas these are your metalloids, okay? This we have already discussed in the previous chapter, so I don't think so we have to discuss this again. If you wish to read more about this, then you can refer to that video, right? If you have any doubt, feel free to comment down below. Then the metallic character of element. Now what do you mean by metallic character? It means a character which is shown by metal, right? And what is the character of metal actually? So metals have tendency to donate electron, and non-metals have tendency to gain electron or to accept electrons, okay? This much we know already. Because metals donate electron, therefore it possesses a positive charge. Because non-metals gain electron, therefore it possesses a negative charge. Now the metallic character of the element decreases as you move across a period on the periodic table from left to right, and it increases as you move down a group, okay? So what are they saying here? This and that, let's refer to this periodic table, okay? So they are saying, we are talking about metallic character. And what is metallic character? Tendency to lose electron, okay? So to lose electron, it means that the electron will be lost from the outermost shell, right? And it should be away from the nucleus. The larger the gap between the nucleus and the outermost shell or the electron, the lesser is the force which will be experienced by this electron from the nucleus. Hence it is easier to remove the electron, okay? For example, we have, this is your nucleus, N is your nucleus, and let's do it again, okay? So for example, I give you these two atoms, which this one is smaller in size and this one is larger in size. And if I ask you in which atom is it easier to remove electron, then you will say that it is easier to remove electron from this bigger one. Why? Because there is a large distance between your nucleus and electron, hence the attractive forces which are present between this positively charged nucleus and the electrons will be lesser. Or I can say that the electron which are present in the bigger atom will experience lesser attraction. from the nucleus and hence it will be removed easily. But in the case of a smaller atom, what happens, because the distance between nucleus and electron is shorter, the distance is less, hence the attraction force which is between the positive charge and negative charge is greater, hence it will be difficult for us to remove this, right? So can I say that the metallic character will be greater in this one, the larger atom, okay, and metallic character will be lesser in this case, okay. Now let's talk about metallic character as we go down the group. So already we have discussed, as we go down the group, the shell increases, okay. Here 1 shell, then 2 shell, then 3, then 4 shells, and then 5 shells. Now from looking at the diagram itself, you can say that as we go down the group, the size of the atom is increases, and hence it is easier for the electron to be removed from the atom, or I can say that the metallic character will increase, right? So let me write down over here, as we move down the group, the number of shells increases, okay, hence distance between nucleus and valence electron increases, therefore force of attraction of, or nuclear force of attraction, we can say, nuclear force of attraction will decrease, therefore electron can be removed easily. And if it can be removed easily, it means that they can show a good metallic character, okay. Hence metallic character increases as we go down the group, okay, down the group. I hope this is clear. Now this was about group. Now let's talk about period. Now when we are moving from left to right across the period, what happens? The shell number remains the same. As in when we talk about lithium, beryllium, boron, carbon, nitrogen, oxygen, the shell number remains the same, which is 2, okay, because they are present in the same period, period number 2. So the number of shells remain the same for this, and then for this, and then for this, and this, okay. Now what is changing if the shell number is remaining the same? What is changing is the number of protons. So the greater number of protons in the nucleus, more is the force of attraction from the nucleus to the electron, and hence the size shrinks, okay. So when we are moving from your left to right across the period, the size of the atom decreases. Why? Because the number of protons are increasing. As we have already discussed that in the periodic table, they are arranged in a way that they are arranged in increasing atomic number, okay. So as the proton number is increasing, the positive charge present in the nucleus is also increasing, hence the force of attraction of nucleus will also increase, therefore the atom size shrinks. Now as the atom size shrinks, the distance between the nucleus and the outermost shell in outermost electron also, the distance decreases and the force of attraction increases, therefore I can say that the metallic character will decrease. So let me write down here, metallic character reduces, okay, as we go from left to right. Why? Because the size of the element or the size of the atom is reducing as the number of protons are increasing. Now if you wish to note down this, then please you may do so. Okay, so this was about it. Now let's read the next point. This trend occurs due to atoms more readily accepting electrons to fill their outermost shell rather than losing them to have the previous already full electron shell as their outer shell. Okay, metals occur on the left side of the periodic table, we know that, and the non-metals to the right. Okay, between the metals and the non-metal lie the elements which display some property of both. So they are talking about this. These are metalloids which have properties of both metals and non-metals. Now let's talk about what are metals and what are non-metals, what is the difference between their properties. Okay, so we have already understood that where are metals present in the periodic table and where are non-metals present. So metals are present in the left side and the non-metals on the right side, and in between of them some metalloids are present. So now let's talk about metals and non-metal. First of all, we have electron arrangement. So what are the electron arrangement? Obviously in metals, valence electron should be less than 4, okay, which is 1, 2, 3, so that they can donate these and they can possess a positive charge, okay. And non-metal, they should have more than 4. Why? Because they have to gain electron. Next is bonding. So metals show metallic bonding. Metallic bonding, for example, lithium is your metal. It will be bonded with electron, free electron. Then further again one lithium, then electron. This is your metallic bonding. Next is non-metal. Now non-metal, for example, your SO2 or NO2, these are all your non-metal and they are bonded covalently, right? What is covalent bonding? The bonding which occurs between two elements when they share their electrons. Okay, next is electrical conductivity. So we know that metals are very good conductor of your electricity and heat, and non-metals are not good conductor of electricity and therefore they are insulators. But there is an exception. What is that exception? Graphite, right? We know graphite. Graphite we use as an electrode while we are studying electrochemistry. Next is type of oxides. Okay, so metal oxides are basic in nature and non-metal oxides are acidic in nature. We have already discussed that in this table. Okay, basic oxides and acidic oxides. Then we'll talk about reaction with acid. Okay, so all reaction, like many metals can react with acid, but non-metals, they do not react with acid. Okay, next is physical characteristic. They are malleable, ductile, they have high melting and boiling points. Okay, so it means that they have stronger forces, therefore they have high melting and boiling point. They are malleable and also they are ductile. Now what is malleable and ductile? Malleable means they can be beaten down to form sheets, and ductility means, ductility is the property wherein you can convert the metal into thin wires, like for example copper. But when we talk about non-metals, they are brittle. Brittle means which breaks down into smaller pieces, and then they have low melting and low boiling point. They do not show the property of malleability and ductility. Okay, so these are some properties. Please note this down. I hope you have written this. So now up till here we have understood that what does the group number and periodic number tells us, or period number tells us. But now let's check that what if we have the electronic configuration, then how will we find out its address in the periodic table? Or maybe I can say that how will I come to know that which period or which group this particular elements belong to? So for that we have this example wherein we have taken a chlorine atom. So chlorine atomic number is 17. We have written its electronic configuration, which is 2, 8, 7. Okay, now 2, 8, 7, which means that how many shells do we see here? We see 3 shells. Okay, the first shell, the second shell and the third shell. So if 3 shells are present, it means the period which it belongs to is 3. So we can say that period number is your 3. And what about the group number? So group number information is given by the number of valence electrons which are present. Okay, or I can say that the electrons which are present at the outermost shell, that tells us about the group number. So here 7 is there. It means it tells us that group is 7 and period is 3. Okay, similarly, if I ask you that you have magnesium with atomic number 12. Now you tell me the address of this magnesium in the periodic table, meaning that what will be the period number and group number in which it is present. So what you are going to do, you have to write the electronic configuration for magnesium, which is your 2, 8, 2. Now how many shells do we see here? 3. So it means it belongs to period number 3. Again, I am repeating, shells are information about shells are given by the period number, and information about the group is given by the outermost electron present in the shell. Okay, so here the outermost electron is 2, so the group number 2 is the correct answer. Period it belongs to is 3. Now let's check for our verification, that is magnesium present in group 2 period 3. Okay, magnesium present in group 2 period 3. Let's clean this. Okay, magnesium is this, it is present in group period number 3 and group number 2, hence verified. Okay, hence verified. So if you have to check in which period or group it is present, just write the electronic configuration. The number of shell will tell us the period number, and the number of electrons present in the outermost shell will give us the information about their group number. Right, now let's move on. So periodic trends in electronic configuration. So till here you must have understood that we can get so many information about any element if we know its atomic number, or even if we know its period number or group number, right? So all the elements present in the same group, they show similar properties. Why? Because they all have same number of electrons in their outermost shell. So this is about that. Element in the same group in the periodic table have similar properties. Like for example, your group number 1. Okay, so this is your group number 1, lithium, sodium, potassium, rubidium and cesium. All of them show similar type of property. If sodium will react with water, the same way potassium will also react with water and rubidium also, and lithium also. Okay, so this way we can predict the properties. For example, we don't know what are the properties of potassium, but still we can predict its property by looking at the group which it is present in. Okay, so we have to check the reactivity of any element in that particular group, and we will know that how this will behave. Okay, when atoms collide and react, it is the outermost electrons that interact. So the very important thing over here is valence electrons, which are the number of electrons present in the outermost shell. The similarity in their chemical properties stems from having the same number of electrons. So this is very important. Why they are similar? Why do they show similar chemical property? Because they have same number of outermost shell electrons. Next is, for example, both lithium and sodium are in group 1 and can react with elements in group 7 to form an ionic compound by reacting in a similar way. Okay, so all of them can react with the group 7 element, which is your fluorine, chlorine, bromine, iodine, in a similar way. Okay, next is your, as you look down a group. Okay, so this we know, lithium, sodium, potassium, group 1 they are talking about. All of them will be having same number of electron, which is 1, right? So because they have same number of electrons, therefore they show similar chemical properties. Now let's try to predict properties of the elements. So because their patterns in the same way elements are arranged on the periodic table, there are also patterns and trends in the chemical behavior and element, their physical properties. Okay, so I have this very interesting table for you here. As we go down the group, the metals getting more reactive, it means the metallic character increases, right? This we have already discussed. And as we go here from left to right, metallic character decreases, right? Because from metals we are moving to non-metals, so obviously the metallic character decreases, also because the size varies. Okay, and atoms getting larger, more metallic. As we go down the group, the size of the atoms increases, hence it becomes more reactive. And the opposite trend can be seen for non-metallic character, that non-metal or non-metallic becomes more reactive as we go above, okay, or from bottom to top when we are going. Okay, now as a result we can use periodic table to predict the properties such as boiling point, melting point, density and reactivity. Some common properties and trends. Okay, I want to show you one table. Okay, here it is. So here we are talking about your group 1 elements, lithium, sodium, potassium. So here electronic configuration is given. Density, you can see that it is increasing and then it falls at potassium. And what about melting point? Melting point decreases. Okay, basically the bonding becomes weaker and hence the melting point decreases. Boiling point again decreases, and the hardness fairly soft, soft and very soft. So the softness increases as we go down the group for your particularly group 1. So there is a pattern which is being followed. Okay, And after lithium, sodium, potassium, let's check the reactivity with gas production. So fizzes slowly a few bubbles. About sodium, because as we go down the group, the metallic character increases, therefore the reactivity also increases, right? Their size increases. Hence, the tendency to lose electron also increases. Metallic character increases, reactivity increases. So, fizzes slowly a few bubbles, fizzes strongly many bubbles, fizzes violently very many bubbles. Okay, so the reactivity is increasing as we go down the group. Heat produced by the reaction, initially it was very low. Okay, it does not melt. Then it melts into a ball on surface and moves about, then melts and moves very quickly. So basically the reactivity is increasing. Similarly with production of alkaline solution and production of flame. Here no flame, then no flame unless held in place. Hydrogen ignites a lilac flame produced, which is your potassium. So it shows a lilac flame. Okay, then we have one more table. Yeah, here. So here we can observe their reaction as we go down the group. So using given information about elements, we can identify trends in properties. As example, when this might be used to determine the, okay. So here, let's understand what I am talking about. This is your group 1. As we go down the group, I told you that the reactivity of metal increases, okay? But for non-metal, it does not happen this way. As we go above, the reactivity increases for non-metal. Here we are dealing with metals. So let's check. When lithium reacts with water, LiOH and H2 is formed. Okay, so if LiOH, which is lithium hydroxide, is formed, then with sodium, sodium hydroxide will be forming, and with potassium, potassium hydroxide will form, and you can see. Okay, same. And hydrogen gas will be evolved, same. Same type of reaction, same chemical reaction. Why? Because the number of electrons in the outermost shell is same. Then observation, relatively slow reaction, fizzing, lithium moves on the surface of the more vigorous fizzing, reacts more vigorously. So basically reaction type is same, but its violency, or I can say that the rate of reaction increases. Okay, or I can say that here the reaction is slow, here it is more vigorous, and then as we go down the group it becomes more vigorous. Basically as we go down the group the reactivity increases. Right, now let's move on to this table here. Okay, so from all of these slides we have understood that if we don't know the property of any element, then we can predict the property of that element by looking at the properties of the other members of the same group, right? The observations show that reactivity of the group metal increases as you go down the group. Okay, so we have information about lithium, sodium, potassium. Next is your rubidium, cesium and francium. Okay, so let's talk about them also. Rubidium, obviously because it lies below potassium, it is more reactive. So explodes with spark. What about cesium? Violent explosion due to rapid production of heat and hydrogen. Francium, too reactive to predict. Okay, it lies at the bottom. It lies at the bottom and you can see what the observations are saying. Okay, so this way one thing is clear, that for metallic group, metallic character, or I can say, okay, for metals, this is important, you can write down, reactivity increases as we go down the group. Okay, for metals, because then they can easily lose the electrons and react. And for non-metals, like for example fluorine, chlorine, bromine, iodine, which is your group 7, what can I say? Reactivity decreases as we go down the group. So opposite happens, okay, down the group, because as we go down the group, the size of the atom increases and therefore the tendency of losing electron and gaining electron also changes, and therefore the characteristic properties of metal and non-metal also changes. Now you can write this. Okay, so this we have already discussed the table and how we can see that the observations are changing, although the property remain the same, that how it is reacting, but then the observation that how fast it is reacting or how vigorously it is reacting, that differs. Okay, that increases as we go down the group. So this is it for today's part 1 of the periodic table chapter. I hope this is very like you could understand the chapter really well. And if you have any doubt, then feel free to comment down below and I will get back to you. I'll be coming with the part 2 really soon. Till then, keep watching and enjoy. Thanks for watching and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.